With another example of a discrete random variable. Again, a random variable is a variable that takes on values with specified probabilities. In this example, a coin is weighted so that the probability of a head is 1/3 and the probability of a tail is 1/3. The coin is repeatedly flipped until either a head appears or 4 tails appear. Let x be a random variable representing the number of tosses. And we want to find the mean or expected value. And we can use a tree here to compute these probabilities. On the first toss, there's a 1/3 chance that it's a head. If it's a head, we stop. There's a 2/3 chance it's a tail. If it's a tail, we toss again. On the second toss, again, there's a 1/3 chance of it being a head. If it's a head, we stop. And we can multiply along this path here. 2/3 times 1/3 is 2 9. So there's a 2 out of 9 chance of getting a tail followed by a head. And then if it's a tail, we toss again. On the third toss, again, 1/3 chance of a head, 2/3 chance of a tail. If it's a head, we stop, and we can multiply along this path. 2/3 times 2/3 times 1/3 is 4 out of 27. 2 tails followed by a head has a probability 4 out of 27. If it's a tail, we toss again. And again, on the first toss, 1/3 chance of a head, 2/3 chance of a tail. If it's a head, we stop and multiply. 2/3 times 2/3 times 2/3 times 1/3 comes out to be 8 over 81. And that's the probability of 3 tails followed by a head. If it's a tail, we also stop because we said we'd stop after 4 tails. So then multiply 2/3 times 2/3 times 2/3 is 16 out of 81. And for both of these last possibilities, we can combine those because the probability x equals 4 can happen in one of 2 ways. That either way, if we have 3 tails followed by a head, or if we have 4 tails, it's still x is equal to 4 tosses either way. So if we add those, we get 8 plus 16 is 24 out of 81, which reduces to 8 out of 27. And then we can fill out a table. The probabilities that we stop after the first toss, get ahead on the first toss, 1 out of 3. And I'm going to make a common denominator here by multiplying top and bottom by 9. Write that as 9 out of 27. Probability x equal 2. The probability we stop on the second toss is 2 out of 9. That's from the tree here. Tail followed by head, we stop on the second toss. It's 2 out of 9. Again, I'm going to get a common denominator. Multiply top and bottom by 3 to get 6 out of 27. The probability the x equals 3, 4 out of 27. That's 2 tails followed by a head, 4 out of 27. And the probability x equals 4 is 8 out of 27. And as a check, you can check that these add up to 1. It should add up to 1. And then we want to compute the weighted mean by multiplying each value of x times its probability. So 1 times 9 out of 27 is 9 out of 27. 2 times 6 out of 27 is 12 out of 27. 3 times 4 over 27 is also 12 over 27. And 4 times 8 over 27 is 32 out of 27. And if we add these, let's see, we have 32, 44, 56, 65. The total is 65 out of 27. So the mean, and again it's a weighted mean, also called the expected value, is 65 over 27, or approximately 2.4 tosses. So on the average, we would expect 2.4 tosses. And we're not going to get exactly 2.4 tosses. We're going to get either 1, 2, 3, or 4 tosses. But the number of tosses is going to be a whole number. But on the average, it will come out to be 2.4 tosses. And that concludes this presentation.